Finally, the last part of Lesson 2, arc and angle relationships. This is Lesson 5 regarding angles where the vertex is outside of the circle. Let's see, so we're going to fill this in. Angles outside a circle can be formed by the intersection of, in this first example, on the left you have two tangents. Then over here you have two secants. And this last one, you have a secant and a tangent. So all three of these are doing the exact same thing where the vertex is sitting outside of the circle. And also, it intercepts the arc, creating a, arc that is intercepted that is smaller, and then an arc that is intercepted on the outside, well, they're both being intercepted between those rays of that angle. So if I extend the ray on this first one, your first angle over here with the two tangents, if you extend it, you still have two arcs that are within that angle, but one is smaller and the other is larger. So between the 2 points of intersection, it divides into two arcs. And in every case, it's going to create a larger arc and a smaller arc. So again, it might help you to think about extending that line to see that it's actually cutting off those arcs from that circle. So I am extending my lines to show that for you. And so notice in this second one here, you've got part of the circle is not even included inside of that angle. It's not being intercepted, it's on the outside. Those arcs out here and out here are not even being used to help us determine the measure of that angle. And on this last one over here, this arc out here is not even going to be used. It's only the arcs that are created inside of those angles. So you will have a large arc that we have in pink, and a smaller arc that is in yellow. So I have the measure of the arcs that I'm highlighting in pink, and I have the measure of the smaller arcs that I'm going to highlight in yellow. And the formula works the same for all of them. And I forgot to drag over to finish this. For all three situations, the measure of the angle is half the difference. Now, when the angle was inside of the circle, we had to add the two arcs together and then take half. But in this case, when the angle is outside of the circle, we're going to find the difference of the two arcs and then take half. So you're always going to subtract the smaller arc from the larger arc to get the measure of that angle. And so you have some examples here, and I'm going to try to work these out for you. And they are worked out on the PDF file as well. So in this case, and let's go ahead and highlight them so we can work with it that way. I'm going to highlight my smaller arcs that are being created by the angles in yellow, and I'm going to highlight my bigger arcs in pink. And so for each one of these, I'm going to subtract the larger arc minus the smaller arc, and then I'm going to take half, and that's going to give me my angle. On the first one, your 220 minus 140 gives you 80, and then half of that would be 40. On the next one, again, it's 92, the larger arc minus the smaller arc. Alright, so you take the larger arc 92 minus the 43, and you take half of that, and that's going to give you the measure of that angle. 92 minus 43 gives us 49. If you take half of that, you would end up with 24.5 degrees for the angle. Now the last one gets a little trickier because we already know what the angle is, so we would put the measure of the angle and set it equal to 1/2 of the large arc minus the small arc, and since the small arc just has an x, then we're going to have to solve to get x by itself. Now remember, in order to get rid of that 1/2, you can multiply times the reciprocal, which is 2, and that gives us 76 equals 180 minus x. And if you subtract 180, you get negative 104 equals negative x divided by negative 1, and x would be a positive 104 degrees. And that is actually the measure of the smaller arc. Now, there is another way to solve for this one, this first one right here. This one is called a circumscribed angle. This is circumscribed because it actually contains the circle inside of that angle. So if I take and extend the rays of that angle like this, you can see that the entire circle is inside of that angle, and we call that a circumscribed angle. And instead of doing this formula, when you know that you have exactly 2 tangents, you have a circumscribed angle. And in order to, another way to do that one, which is much quicker, is this formula on the bottom section. It's simply the measure of the angle is equal to 180 degrees minus that smaller arc. Well, back here our smaller arc was 140. So if I did 180 minus 140, then you would have gotten the angle measure of 40 degrees. So that's a quicker way to do this first one where you have 2 tangents. Instead of subtracting the large arc minus the small arc and then taking half, if you have 2 tangents, it's called a circumscribed angle, and you can therefore just use the circumscribed angle formula. So it's 2 rays that are formed by tangent lines. It's 180 minus the measure of the central angle. By central angle, they're actually saying this angle here because the smaller arc is going to be the same thing as that angle. And this concludes Lesson 2, Arc and Angle Relationships. So we're going to do a graphic organizer and try to get all these formulas figured out and practice. And we will continue on and learn segment lengths in our next lesson. Thank you very much.